Namaste to all of you. Okay, today, now present we are discussing about the complex numbers. Okay, complex numbers. While enter into this chapter, complex numbers, few students they asked me doubts regarding probability. So first, let me clarify those doubts. Probability. Okay, few bits are there. Okay, here the bit is one example. These are the probability doubts. Here the example is, just I will read the question, and then if you are interested, use the pause button and you can note the question also. Here the question is, let P comma Q are chosen by the set by or from the set by the set. Here it is given as 1 root 2 root 3 2 e pi. These are the values with replacement with a replacement. So here P comma Q are chosen from this set. This is the set they given. This set contains 1 comma root 2 comma root 3 comma 2 comma e comma pi. With replacement they are chosen. Now a circle is constructed taking PQ as its center. Now a circle with PQ as its center. PQ as its center. Now the probability, then find the probability. Here the it is. Then find the probability that the at most 2 rational points exist on the circle. Okay, then find the probability that at most 2 rational points exist on the circle. At most 2 rational points. So if you construct a circle with the PQ as a center, then automatically what is the probability that the circle contains at most 2 rational points? Means rational points only 2 only. Rest of all the points are irrational points. Then what is the probability on the circumference of the circle to contain at most 2 rational points? What is the probability? So here we can calculate the probability. 1 minus all rational points probability. Okay, our requirement is at most 2 rational points. At most 2 rational points means only 2 rational points possibilities are remaining, all the irrational points only. So here instead of calculating that value, what I am doing, 1 minus not only 2, all points are rational points on the circumference. Okay, that probability I will subtract. If I subtract now, I can get the required probability. Now, for example, here if you observe, P comma Q are chosen from this set. So automatically here 1 minus, what is the chance will be here? It is 1, 2, 3, 4, 5, 6. So for P 6 chance is there. For Q also 6 chances is there. Now to get the rational points, this center should be rational. The center should be rational. Then only all the points will be rational. For example, if any one is irrational on the circumference, if you take any point as irrational, otherwise if one of the coordinate is irrational, then compulsory here the points on the circumference will be at most 2 rational points only you will get. That means all other are irrational points. Here the simple logic is, this is a circumcircle to one triangle only. For one triangle, this circumcenter and the circle acts as the circumcenter. In order to get the rational point as the center, compulsory these points should be rational points only. If one of them is irrational, compulsory this will contain at most 2 rational points only. So here I am taking here the probability of non-requirement. What they are asking? At most 2 rational points probability they are asking. So what I am doing here? All rational points containing probability first I will calculate. After that, the total probability I can subtract from 1. So 1 minus, if the center is rational, rational means these are also rational number and these are also rational number. Then if I subtract these cases, then the requirement is what are they given I can get. Then what is the rational center, rational point as the center? Chances here, maybe the center will be 1 comma 1 since they are selecting P comma Q as the replacement. So first they are picking one number, again replacing there only. Again they are picking one more number. So maybe the center will be 1 comma 1 or 1 comma 2 or 2 comma 1 or 2 comma 2. If these are the centers, then automatically all the points on the circumference will be rational. But I don't want that particular cases. I have to subtract. So here what is value? 1 minus total how many cases are there here? 4 cases. Simplify this value. D times 2, 3 times. Which is equal to 1 minus 1 by 9. Which is equals to 8 by 9 is the probability. Okay, this is the bit. One of the student asked me. This is the bit. Next, one more example. Here the example is probability only. This is the next doubt. Here the example, if A and B are chosen randomly from the set containing 1, 2, 3, 4, 5, 6. Okay, then the probability that A power x plus B power x, here of course limit x tends to 0 they given. Limit x tends to 0. A power x plus B power x by 2 whole power 2 by x is equal to 6 is, this is the value they given. Okay, so here A and B are chosen from this set. Then probability that A power x plus B power x whole by 2 whole power 2 by x as limit x tends to 0 is equal to 6. Then what is the probability? This is the bit. So here if you observe, first of all, by data, limit x tending to 0, A power x plus B power x by 2 whole power 2 by x, this is the value they given. Directly substitute the value. If I substitute the value as x tending to 0, what about this value? A power 0 value 1 plus B power 0 value 1, 1 plus 1, 2 I can get. 2 by 2, 1. Then here it is value 2 by 0 means infinity. So this is in the form 1 power infinity form. This is 1 power infinity form. So here what we can do, since 1 power infinity means which is equals to e power limit x tending to 0 f of x minus 1 into g of x. This is the basic concept, limits. So you can observe, if anything limit x tending to some 0 f of x power g of x is 1 power infinity form, then how you can calculate this value, then this value limit x tending to 0 f of x power g of x, you can written as e power limit x tending to 0 f of x minus 1 into g of x. In our classroom notebook, this concept is given. Just one time go through it. So here how you can write this total value, a power x plus b power x by 2 minus 1 into f of x minus 1 into g of x. What is g of x value will be, 2 by x. Already this value they given as 6. So simplify this value, which implies e power limit x tending to 0 extending to 0. What about the value here? LCM 2 you will get 2 get cancelled. Then here you can get a power x plus b power x minus 2 whole by x is equal to 6 is the value. From this one, how I can write this total value, mom? E power limit x tending to 0. This value a power x minus 1 by x plus b power x minus 1 by x I can write, ma. This value is equal to 6 is the value. Simplify this value. That implies what is the formula for this a power x minus 1 by x means, ma, logarithm of a. And this is the value logarithm of b. So logarithm of a plus logarithm of b. What is the value logarithm of ab? So you will get e power logarithm of ab is equal to 6. Means ab is equal to what is the value? 6. So ab equal to 6 means then you can take the favorable cases, ma. What are the favorable cases will be? 1 6 6 1 2 3 3 2. Total 4 cases will be there, and 5 p2 you are selecting, na. So 4 by 6 into 5 is the value. Simplify. If you simplify, you will get the answer. Okay, cross check one time. You are selecting 2 numbers, na. If you select 2 numbers means, ma, then you will get the answer. You can cross check one time. Next, basing on the options, ma, here they given 1 by 3. So 4 options by 6c2 into 2 if you take it, 2 3 times, then which is equals to 4 by some 15 like this. 2 by 15. 6c2. You can cross check my yourself. ABR how they chosen? ABR chosen randomly from the set consisting numbers. So out of with replacement. Sorry, ma. Here with replacement they given. Na? So with replacement means here the total probability equals to, here I am telling, with replacement means here 6 into 6 only. Here how many cases? 4 favorable cases are there. Simplify, you will get the answer. Okay. So with replacement means first one number they chosen, then again they replace there, then again they chosen. So there are total 6 into 6 chances will be there. So these are the total cases, ma. Out of these total cases, how many favorable cases are there for us? Only 4 favorable cases are there. You can proceed. Next, one more example, ma. Listen all of you. Okay. Here the next example is, ma'am, probability of n heads in 2n tosses of a fair coin can be given by, this is the value, probability of n heads in 2n tosses. So you can apply the probability of the binomial distribution. So out of 2n times, you have to get n times head. Probability of getting head chance is 1 by 2. So here it is 2n minus n, you will get 1 by 2 whole power n. If you simplify 2n cn, 1 by 2 whole power 2n is the value. Just you can cross check the options, which you will get. This is the probability directly. Okay, from the options you can cross check. This is the bit. Next, one more example, ma. So here a bag contains, one more example, ma. Listen all of you. Bag contains, here the question is, bag contains 10 different balls. Bag contains 10 different balls. Okay. Out of these 10 different balls, 5 balls are drawn simultaneously and then replaced. First, 5 balls are drawn. 5 balls are drawn and then replaced. And then 7 balls are drawn. And then 7 balls are drawn. 7 balls are drawn. Okay. If the probability that exactly 3 balls are common to the 2 draws. Okay. According to given data, they are telling that they are containing 3 balls common. 3 balls common in the first draw. Then is P they given. Then what is the value? 8P. So here required probability is equal to, listen all of you. So here 3 balls are common. 3 balls are common. For example, first they draw 5 balls. This is the first completed. They draw already 5 balls. After that they draw the 7 balls are drawn. So here out of 10 you are selecting 7, 10C7. This is the value 10C7. Then according to data here 7 balls are drawn, but out of these 7 balls what we draw here 5 balls, exactly 3 balls will be common. 3 balls will be common. That is the logic. So in order to get 3 balls are same, out of these 5 only you can select 5C3. Okay. For the second you are choosing 7 balls. You are selecting 7 balls. You are selecting 7 balls. Out of these 7 balls, according to given data, there will be 3 in common. So 3 in common means, for example, these 10 balls, you can divide like that. First draw 5 balls, next 5 balls remaining will be there. To get 3 balls common, out of the first draw 5 balls, you can select 3. Then remaining 5 balls, you are selecting 7 only. So already 3 you selected here. Then rest will be different. So here it is 5C4. Then simplify, you will get the answer. And one more thing, here maybe in Singh's book or some other books, for this they given one more answer. But my explanation is like this only. This is the bit similar to if A draw 2 cards, if B draw 2 cards, then find exactly there will be one common card. Like that. Okay, if A draw 2 cards, similar kind of bit also previously we explained. A draw 2 cards, after keeping again B draw 2 cards, then find the probability there will be exactly one common card. So here the explanation is like this. I am giving explanation. If any objection is there, you can one more time you can ask. Again we will discuss if any genuine doubt is there with you. Next, after this, few more doubts. Here one bit is there here. Next example in probability. So here the next example is given. Listen, next example. Cards are drawn one by one at random from a well shuffled pack of 52 cards until 2 aces are obtained. So here cards are drawn one by one at random, one by one at random from well shuffled pack of 52 cards. 52 of course playing cards. 52 playing cards until 2 aces are obtained. Until 2 aces are obtained. Until 2 aces are obtained from the first time. From the first time. From the first time. Then the probability that 18 draws are required. 18 draws are required for this. 18 draws are required for this. What is the value? Listen here. So here if you observe, 18 draws they did. 18 draws they did. So total here the total cases is equals to out of 50 to 18 we have to select. Okay. Cards are drawn one by one at random from well shuffled pack of 52 cards until 2 aces are obtained. Okay. Then find first time find the probability. Otherwise here according to given data one by one at random they given. One by one means instead of this one, okay, you have to take 52, 51 like that 18 times. At random is different, one by one is different. Cards are drawn one by one at random from well shuffled pack of cards. So here the total value 52 into 51 into like this you may get it 18 times. Next if you observe the favorable case, I will tell you for this one. What is the favorable case? Here the 2 aces are obtained. That is the logic. 2 aces are obtained. That too 18 draws are required for this. 18 draws are required for this. So 18 draws are required for this means in the 18th draw, we will get second ace card. That only na. Gatma. Here 18 draws, 18th draw. In that 18th draw, we are getting second ace card. That only na. Then only 18 draws are required. For example, 18th before only. 18th draw before. If you will get any ace card, then there only our 18 draws are not required. Na? Why? Because our experiment is drawing the cards till 2 ace cards are obtained. So 2 ace cards obtained means till where we have to do that too they mentioned 18 draws are required for this. So 18 draws are required means in the 18th draw we are stopping the drawing of the cards from the well shuffled pack of cards. Means indirectly what is that logic mom? In the 18th draw we are getting the second ace card. So in the 18th we are getting second ace card means before how many completed 17 draws we completed. But out of these 17 times compulsory one ace card will be there. One ace card means 4C1. One ace card will be there. Out of 52, if you subtract the ace cards 4 then how many? 48 remaining cards will be there. So out of these 17, compulsory one ace card is there. So out of 4 ace cards you can select one, and remaining 16 cards are out of these 48 cards we have to do. So how you can take here, it is the value 48 into 47 into like that you have to take 16 times is the value into in the 18th draw. In the 18th draw, second one more ace card you are drawing. So one more second ace card means already you draw one ace card here. So remaining how many ace cards will be there? 3. You have to select 3C1. Therefore probability is equals to 4 into 48 into 47 into like that here by reducing like this 16 times into 3 by denominator value 52 into 51 into up to so on how many times 18 times you have to take it. Maybe major part here it will be cancelled. Simplify, you will get the answer. Okay, once again let me explain. Here the bit is cards are drawn one by one. This is important. One by one. Why this is important means here the thing is cards are drawn random. 18 cards are drawn random. In that case the total cases are 52 18. But here it is not. 52 cards are there. One card first. Next one card. One by one drawing. So one by one means you have to take the total cases as 52 into 51 into up to so on how many times? 18 times. Then here from a well shuffled pack of 52 playing cards until 2 aces are obtained. So here our favorable cases is 2 aces we have to get. Then here from the first time, then find the probability 18 draws are required for this. So your experiment drawing one card. How many times you are doing? 18 times. After 18 times, according to given data, you stopped. After 18th time, you stop the experiment means, what is that meaning? 18th time, you are getting the second ace card. So, automatically here, 18th time you stopped. In the 18th draw, you got the second ace card. Means before how many experiments you completed, ma? 17 times you draw. In these 17 times, what is that logic? In these 17 times, you draw one ace card. So, what is the favorable case, ma, here? Total how many ace cards will be there in the pack, ma? Already you know. Okay, 4 ace cards will be there. Out of these 17 times, one ace card should be there. So 4C1. Even that ace card also, out of 4 you will get 1. So 4C1 means 4 aces into. But out of these 17 also, 16 times remaining cards you are getting other than ace cards. So if you delete ace cards, how many non-ace cards are there? 40 cards are there. So out of these 48 into 40 sound like that, 16 times you can mention. After that, 18th draw. In the 18th draw, what about the value will be more? In the 18th draw, again you are getting the second ace card. Already you draw one ace card now. If you draw one ace card, then the remaining are 3 ace cards are there. Out of 3 ace cards, you will get one ace card. That is nothing but 3C1. Okay. This is also a bit more. A few students, they asked me regarding this bit. Next one. Next, one more example. Here it is. Here the probability, listen all of you, the probability that a teacher will give an unannounced test during any class meeting is 1 by 5. Means teacher will conduct a surprise test. So probability of surprise test conducting chance is 1 by 5 is the value. If a student is absent twice, then the probability that the student will miss at least one test. Miss at least one test means maybe miss at least one test probability, or probability of missing at least one test. At least one test means what the probability we have to count here? One test missing plus two test missing. One test missing, two test missing. So he absent 2 days, mom. So between 2 days for this one test missing. One test missing means between 1 day. Out of these 2 days, 1 day, teacher conduct the exam. He missed the test. So out of these 2 days, 1 day you cancel 2C1. Missing chance. What is the missing chance here? Missing chance means teacher conducting the test. Means that conducting surprise test is 1 by 5. And the second day not conducting, like this. Next case, 2 tests missing. 2 tests missing means what he missed those 2 days, there is no surprise test. Means like this. What he missing, sorry, here 2 tests are missing. 2 tests are missing means in those 2 days, he absent 2 days na. Those 2 days surprise test will be there. Then only he will miss na. So here you may get it, here it is the value 1 by 5 into 1 by 5, like this. Simplify, you can cross check. Once again, listen. Probability of missing at least one test. Probability of missing at least one test means maybe between these 2 days, test will be there 1 day. Okay. So out of these 2 days you may select any one day test will be and the second day test will not be. Obviously he option 2 days na he will miss the test. Plus otherwise these 2 days there will be test. What the student absent those 2 days test is there, automatically he will miss na. So 2 days for 1 day surprise chance is 1 by 5, automatically 1 by 5 plus 1 by 5, then simplify you will get the answer. Next, here it is the value total. If you simplify, here it is 4 2 are 8, 8 plus 1 9, 9 by 25 you will get this value. Next one more example is there. Listen, one more example. Here the example. A box contains tickets. One box. A box contains, here the tickets numbered from 1 to 20. A box contains tickets numbered 1 to 20. Numbers 1 to 20. 3 tickets are drawn from the box with replacement. 3 tickets are drawn with replacement. One by one with replacement from the box with replacement. With replacement. The probability that the largest number on the ticket is 7. Probability that the largest number on the ticket is 7. This is the bit. Okay ma, once again listen all of you. A box contains tickets numbered from 1 to 20. Here this is the example ma, one example. What they did ma, 3 tickets are drawn with replacement. 3 tickets are drawn with replacement. Then find the probability that the largest number on the ticket is 7. Okay ma. So here required probability is equals to, first of all, for example, first I can take 2 7 ma. Here the total cases, if you count, how many total cases will be ma? Here it is with 3. So total cases you will 20 means they draw 1 ticket. Observe it again, keep in the same place. Once again they draw like that. So total cases are 20 20 20. Then probability equals to 20 20 20. According to given data, probability that the largest number on the ticket is 7. Largest number on the ticket is 7 means, first here I can take how many case will be the x less than or equal to 7. X less than or equal to 7 means each and every ticket up to 7 only you can select with replacement. That means first 7 chances, second 7 chances, third 7 chances. From this I am subtracting x less than or equal to 6. What is this meaning? X less than or equal to 6 means up to 6 only you can subtract it. Up to 6 only. So up to 6 means again 6 into 6 into 6. So total value is equal to 7 cube minus 6 cube by 20 cube. This is the probability. Maybe student point of view little bit confusion. How it came? Why you are selecting first time up to 7, next time up to 6? Simple ma. Here the up to 7 I am selecting in the first case. Up to 7 I am selecting means maybe here you may get for example 2 comma 2 comma 7, like this you got it. Minus within these cases, such a kind of cases, maybe 2 7s will be there and 3 7s will be there. All these selections will be in the first case. But here I am subtracting, exclude these cases. Why I am subtracting? Out of these the first cases, out of these 7 cube cases, few cases will be there. Maybe you will get like this also, 1 number 2, 1 number 3, 1 number 4. but here there is no greater value 7. Such a kind of selections I am subtracting. So here 7 containing cases compulsory and without 7. In the first case, if you observe, without 7, with 7 cases are there. From with 7 I am subtracting without 7. So here first one is without plus with 7 cases I am subtracting without 7 cases. If I subtract without 7 cases, what I can get with 7 case only I will get. That is only they are asking. They are asking largest number on the ticket is 7. So automatically with the 7 cases means what we draw compulsory 7 is the largest value and the remaining are less than 7 only. That's it. This is the explanation for this one. Okay. If you have any doubt more, one more time you can listen the explanation, you can understand. Here the first case is without 7 plus with 7, all cases are there. From this I am subtracting without 7 cases. Then automatically you will get with 7 cases. Means compulsory 7 should be there. That's it. Thank you.